So everybody that's on currently, I'd like to thank you for joining our Rexel webinar. And as you know, or you might have found out, this is a series of ones we're doing that kind of help out with network layout, security, and some of the design aspects of putting together a secure and productive plant-wide Ethernet system. And we had one a few weeks ago that covered just kind of everything in general, and we're going into a little bit more depth now. So Warren Lennox is a person from Rockwell that works in their network services group that is going to talk today about the converged plant-wide Ethernet. And that's a model which Cisco and Rockwell put together that really help with kind of the proper design of the plant networks and how to put together an architecture that's very supportable and something that can be built off of for a lot of robustness and redundancy and the ability to put a lot of security aspects into it as well. So with that said, we're going to kick it off to Warren here. And then I just did want to give a heads up. You'll get an invite for some more in the future. We're going to do one coming up also on with Fortinet, which is another partner that keeps care of security deep packet inspection and segmentation networks. And then we're going to have one on disaster recovery coming up. So every few weeks we'll have another webinar with another person, and kind of go a little bit more depth in subjects that kind of help out with that aspect of your journey. So with that said, I'm going to turn it over to Warren and let him introduce himself. So
thank you everybody. As you've heard, my name is Warren Lennox. I'm based out of Los Angeles, been with Rock Automation about 18 years, varying roles from tech consultants to solution consultant. And since COVID, I've been involved particularly in the network space. The accent you're hearing is South African, so if it confuses you a little bit, I'll try and keep it American as best as I can. The goal of this presentation will be roughly 45 minutes. I will be going through really a high-level overview of the CPWE. So really the goal here is to help you understand what it is. So if someone brings it up in any of your sales discussions or any of the technical people in the room, I'm looking to develop architectures and trying to develop that according to a framework, a recognized framework. I'll go through some of the challenges involved. We'll talk about some of the customer feedbacks who have implemented this. And then at the end of it, I'd like to show you a brief demo from a tool called Integrated Architecture Builder. It's a software utility tool that will help you build an architecture from scratch utilizing the CPWE model. So please go ahead if you have any questions, put that in the chat. John will be able to respond to that. And as soon as I've finished the presentation, I'll address anything outstanding. And hopefully you enjoy the presentation. All right, so let's take a look at what's happening in the marketplace today and what the effect is on industrial operations. There are a number of market pressures that are putting productivity and profitability at risk for manufacturers. First, there has been rapid globalization, which opens up new opportunities. In fact, $25 trillion in GDP growth has been attributed to globalization from 2000 to 2016, and this in turn has led to a highly competitive marketplace. Industrial operations are struggling to increase product output, work productivity, and cost efficiencies to keep up with the global demand, but are hindered by aging infrastructure. 87% of manufacturing executives report that aging infrastructure impacts their operations. Another significant challenge in today's market is the increasing number of security risks and threats. Cyber threats and attacks can result in extended periods of downtime, compromised intellectual property, and the loss of millions of dollars in revenue. In fact, roughly 28% of manufacturing organizations reported a loss of revenue due to security attacks in the last year, and that has just been increasing exponentially every year. Add to these challenges the continued influx of data from growing number of industrial IoT devices. This is expected to grow exponentially, 3.2 billion in 2020. We're way beyond that at this point. And it's apparent that the existing and aging infrastructures just cannot cope. So what we really need here is a modernization through digital transformation. So incorporating new digital devices that have the properties to be able to enable this framework. So digital transformation through modernization is needed, but modernization can be complex and must address numerous pain points. For example, aging infrastructure has resulted in proprietary networks and services which have increased the complexity of the networks. Limited security in the current network infrastructure has not been robust enough to mitigate newer and more sophisticated security attacks. As we saw in the previous slide, security threats can rarely compromise the operations. The scale and volume of data is ever increasing, but data historically has been difficult to capture and manage. There is a skills gap currently where this traditional OT workforce is not ramped up for the IT implementation and management. There's a need to provide the appropriate training and educational resources for these teams. There has also been many potential solutions in the market, and choosing a solution that addresses these challenges can be overwhelming. Any solution you choose must be able to handle the volume and scale of data being generated through the introduction of IoT devices and the migration of OT to IT. And this is certainly where Cisco and Rockwell have been developing an application for many years, and we can help customers deliver this. So looking at operational outcomes for IIoT, industrial IoT architectures, what are the kind of things that you should expect? So the key over here is really having the correct protocol. So in our case, devices should be Ethernet IP. It should be of the industrial OT, IoT technology. It should be hardened for the appropriate applications. So we talk about industrial ready applications and industrial ready pieces of equipment. And it should be ODBA conformance tested. So that's the ODBA being the governing body for the Ethernet IP protocol. We should be looking to give our customers a good choice, a large install base of best-in-class products for the IoT devices that can live in a cohesive environment as well as being interoperability between each other. So be able to communicate with a bunch of different devices that are able to strengthen their technical ability on the floor. It's very difficult to be confined to IoT devices that only have certain parameters and certain technologies available to them. Another area is the connected architectures. So what we're looking for here is a standard network technology and standard network tools that can be applied by both the typical IT engineers as well as the OT engineers. The architecture should be scalable. This is one of the issues we've seen when architectures get built. They really get built sometimes appropriately for a single application, and when it comes time for the customer to expand that application or make it more scalable, challenges get introduced, and in some cases, they're not able to expand appropriately. And they should be able to deploy this with a focus on availability to minimize the disruption of operations. I'll touch on this a bit more in the deck, but it's important that all OT operations are really focused on high available systems, so networks that have fault tolerance techniques and have the ability to find a second pathway in the event of a network collapse. As I mentioned before, the system should be open to partners who can continue to expand on the smart enabled environment, adding technologies to solve the business needs as they arrive. The system should adhere to industrial standards specific to your industry to ensure compliance to the governing bodies that you serve. The CPW specifically has been developed with the NIST and the IEC 62443 framework in mind. And finally, it should have a balanced security stance to take advantage of the OT innovations and while still maintaining the integrity of the industrial safety and security best practices. If those are interested, we do have a solution called Plan PX, which is a complete off-the-shelf, out-of-the-box SCADA system. And if configured according to the user manual, you can get a certified IEC 62443-3 system up to a security level of 1. So that system is called Plan PX for anyone that's interested. So Cisco Systems and Rockwell Automation together are leading this digital transformation for the connected enterprise with industrial-ready, world-class systems in IT networking and security technologies. The Cisco and Rockwell Automation Alliance is highly strategic and brings together trusted domain expertise in OT and IT. Rockwell Automation has a deep knowledge and expertise in OT, and many of our OT products are deployed as part of the industrial operations infrastructure today. Cisco is a worldwide leader in networking and security with a broad offering of production-proven products and solutions with an established install base in the manufacturing industry. Both partners have been working together for over 16 years, and during this period of time, Cisco and Rockwell Automation continue to prove their commitment to the future success of the industry. They offer together targeted education, skills training, and outreach programs that help the workforce stay current with digital transformation innovations. Training the workforce is not the only outcome of the partnership. As part of the long-standing collaboration, Cisco and Rockwell Automation have jointly developed a groundbreaking solution for a converged infrastructure and connectivity that will help you leverage the power of your data. You can rely on unparalleled industry expertise and validated solutions to address your specific manufacturing needs. So with that, I'd like to introduce the Converged Plant-Wide Ethernet Guide. One of the outcomes of the partnership is really trying to create a blueprint that all customers can adhere to, something, as I mentioned before, that adheres to the standards. This diagram illustrates the CPWE simplifies network design by connecting industrial operations with the business system. This is really the key strategy. How do we connect the industrial plant floor in a secure and high available method into the enterprise space and then up into the clouds as well? So the silent networks of the past can now be integrated into the CPWE architecture, providing greater real-time visibility into the state of the industrial operations. The seamless connectivity is achieved through the use of open systems that adhere to regulatory standards, which enable flexibility and scalability. Proprietary systems can now be integrated without the need for a forklift upgrade, thereby preserving the investment in the infrastructure while paving the way for innovation. One key innovation is the ability to leverage IIoT data from smart devices in industrial operations. With CPWE, you can now build a common architecture framework which makes the network data ready and provides you with the tools to efficiently transport, store, and manage data for key business insights. CPWE provides a lot of benefits to all industrial applications. So this model that you see here is applicable to most industries out there. So a lot being said there, but certainly moving from a traditional architecture to a converged architecture certainly has its challenges. So let's touch a few of these. So what we see over here is what we call a traditional organically grown system. By that I mean, as the Ethernet is adopted across the plant floor, we have these islands of automation, and over time, the system engineers just simply connect all these devices together. And we end up with a large, flat network. Easy to use, easy to access. However, under the hood, there are many concerns about this kind of architecture. If you look at the diagram over here, the issue with the flat architecture is that it contains many technology disciplines. And by that, I'm talking about, in this case here, we're looking at drive applications, we're looking at safety applications, and we're looking at motion applications. So anyone familiar with programming any one of those, each one of those disciplines requires a different performance characteristic and resiliency characteristics for their particular applications. And really, you have to design according to those applications to get optimal throughput of the machines, to get them to behave in a non-latent fashion. So by migrating from these isolated LANs to a large, flattened open LANs, we lose the boundaries and the natural segmentations of the equipment. Instead, we should be creating segmented networks with smaller LANs and boundaries. This allows us to isolate the different disciplines and ensure the appropriate rules of traffic are applied to each zone. Also, from a security perspective, a segmented network provides the ability to create what is called defense in depth, which I'll cover in a couple slides. Essentially, it makes it harder for an adversary to penetrate the system by creating more subnets for them to jump through. So, putting it all together, this is the diagram of the Converged Plant-Wide Ethernet Guide. I'm sure many of you have seen this before. I'm not going to get into a lot of detail of every area within this, but I'll give you the high-level overview. So, essentially, we're looking at the Purdue model. If you see the zones at the bottom over here, it says zones 0 through 2, 3, and 4 and 5 up here. These are referencing the Purdue model, which is really a way to organize the levels of data. So the very blue layer over here, which is where most of us are familiar from the OT space, which is your PLC to IO communications. So we're talking about programming PLCs, establishing class connections to the IO. We're looking at low latent networks. So in this space over here, any latency in the network will drastically affect the performance of the equipment. The space up here is the IT area. So myself, I'm still learning a lot about the IT space. It's not something I've had a lot of experience with. I've been on the OT floor for the majority of my time. But this is certainly a great way for these two teams to start communicating and understanding the way traffic traverses across this network. In the middle level here, we call this the industrial IT or the site level operations. This is where your SCADA systems would reside. So all your software servers. For a Rockwell application, this would be your FactoryTalk layer. You'd have a FactoryTalk directory, your FactoryTalk view servers, your historian servers, anything to do with grabbing the data from the industrial OT level, the blue area, and bring it up to a presentation area where you would deliver that information onto a screen for the operator to control the system. And then finally, we have the IDMZ. For the people on the call not familiar with the IDMZ, this red area is really the critical area of most control systems. And I'm still surprised today to see so many customers not deploying the IDMZ. The purpose of the IDMZ is to be able to create a space whereby we can share data across these two regions without crossing the boundaries. I'll give you an example. If on this space down here, let's call this the OT area, I've got a historian server and I have some data. I've got historical data, or perhaps it's machine data that the IT area need access to. I'm not going to poke a hole through the entire system all the way down to my servers down here and allow them to remotely connect and retrieve the information. Instead, I'm going to create a copy of whatever I have up here inside the IDMZ. So I'd replicate a historian up here, and then the teams up here will be able to access the data, but not be able to penetrate through the firewall, and vice versa. On the OT side, they'll be able to get into the firewall, but not be able to penetrate the IT. So that's really the essence of the IDMZ and the structure of the CPWD. Of course, there's a lot of challenges. There's different entities involved in this over here. So if we look at some of the differences between the systems, down here, we're talking about the software and the hardware tool sets. An IT person is not going to be familiar with the Studio 5000 programming package and be able to program a PLC, and vice versa. The guys in the OT space would not be familiar with TLS or security aspects with regards to the IT. There's a lot of technical differences with regards to the resiliency protocols required on these networks down here and the ones up here. I'll talk a bit more about the quality of service policy, so how you set a precedence for the type of traffic flowing through the wire. And of course, there's different applications. Up here, we're using WebEx, and down here, we're using SCADA systems. And of course, there's different parameters around remote access to these systems. So it can be extremely challenging for these groups to get together. And in most cases, there are different groups. There'll be a firewall group that programs and watches the firewalls. IT people do the majority of the work. Down here, we've got the OT space where a bunch of technologies are residing. So let's look at a couple more differences between the two systems. I've done a lot of work in the factories. I can tell you now that a factory control room is completely different to that of an IT office. We're talking about, in most cases, a corrosive environment, very dusty, could be a little vibration, could be very hot. And then the inverse of that, obviously, on an IT space, the majority would be in an office where it's air conditioned, thereby saying that the equipment required for these two places are completely different. Trying to put a non-industrialized switch onto an industrial floor, that switch is not going to last very long. Excuse me. Look at the order of precedence. So if we look at the control floor, I mentioned earlier that the availability of the network is critical. The moment my network goes down, I stop production, we stop producing revenue. The inverse of the IT side is confidentiality. So they're looking to secure the data. If a machine goes down, it's not drastic. They're able to go to a different machine, or they can wait until someone repairs that. And it really plays right into something like the service level agreements. If you're looking to get someone on site to fix your OT space, that's going to be done within minutes, in some cases even hours. But on the IT side, their service level agreements are already hours and days. And then down here is the type of traffic, really something to consider. This is the quality of service on a control system. We have network and control information and safety data and motion. So any one of these protocols, if the quality of service or the precedence of that packet was provided behind something like video and voice, if anyone picked up a phone and started calling someone, we could see disruptions in the traffic on the OT space. So some huge differences between the two environments, and really something to consider when designing the two different systems. Excuse me. So as I mentioned earlier, from the security side of the system, what we use is called a defense in depth approach. It's critical to understand that there is no single solution or tool out there that will completely protect you from attack. All we can do is both identify and delay an attack through countermeasures and policies. The defense in depth security approach addresses internal and external security threats. This approach utilizes multiple layers of defense, both physical and electronic, at separate industrial levels by applying policies and procedures that address different types of threats. For example, multiple layers of network security protect network assets, data, and endpoints, and multiple layers of physical security to protect the high-value assets. I just want to repeat that. There is no single technology or methodology out there that can fully secure you from an industrial attack. All we can do is place these measures in place to be able to slow the attacker down, identify the point of entry, and protect and respond and recover to that attack. We've been on this journey with many customers, and just a couple of the highlight ones I'd like to present over here. So Jack Daniel's Distillery from Lynchburg, one of my favorite customers. That's a couple of business challenges, including controlling operational costs. They were trying to reduce unplanned multi-line outages to do with overall equipment effectiveness. They found it difficult to troubleshoot and maintain a network infrastructure with ease to reduce the mean time to repair. And they were struggling to enable scalability, as I mentioned before. They were trying to expand the production facilities, and the systems just weren't capable, weren't future ready, weren't able to be expanded. So we spent some time with their teams. We had a bunch of meetings, workshops, as we call them, to understand the best practices of the CPWE, looking at the network and security aspects. We deployed Stratix 5700 industrial Ethernet switches. I'm going to touch a bit more on the actual portfolio of switches that we have available. We also brought in the Cisco Catalyst 3850 distribution switches on the distribution layer, and then we wrapped that around with the FAT production and performance suite to handle all the software aspects of the application. So this customer enjoyed a revamped industrial network architecture, and we had no disruption to the production floor. They had better asset optimization through scalable and more standardized, reliable, secure, and future-ready systems. And they had better business agility through OT and IT connectivity across the enterprise. So we were able to retrieve the information from the OT space, from the machines, and then have that presented up in the IT space through the IDMZ in a secure and safe manner. Another customer, the Daimler production facility, their challenges with delivering customized vehicles for consumers. They were trying to do it better and faster. They were trying to control the costs by boosting the manufacturing efficiencies. They're trying to improve agility and scalability to support innovation and future production needs. Again, we sat down, did some workshops, discussed the CPWE best practices, focusing on the network and security areas. Again, we deployed the Stratix 57, and in this case was the Stratix 8000s as well. They had a larger requirement for distribution switches, so we introduced the Cisco Catalyst 3850 and the 4500 distribution switches. Daimler also required wireless access, so we introduced the Cisco AeroNet 3700 access points and the 5508 wireless controller, and again wrapped it up with the FAT production and performance suites to handle the software. So the customer enjoyed fantastic, pervasive wireless connectivity, and this allowed all the employees as well as the managers to connect to the plant anywhere. They're able to share information quicker, and the production manager informed us that they were well more informed about what the production floor was doing based on the ability to access the information that traditionally was behind these different gates. We managed to meet the requirements within the industry, so there's a standard-based security environment, and we managed to meet the compliance requirements for the facility. Okay, so as you can see from these examples, Rockwell and Cisco have been leading the digital transformation effort by helping customers become more profitable while moving them towards a standard-based architecture targeted at addressing business outcomes to improve agility, optimizing production yield, and minimizing the business risks. By establishing an architecture blueprint for their success, expanding companies get a foothold on their competition, reducing the time to market and the cost for global expansion. From my experience, the CPW is the glue that's been bounding these teams together and provides invaluable information on how to address the network needs across the infrastructure. I'm going to dive a bit more technical now. That was the high level area. We'll go a bit more technical into the reference architecture. So what is the reference architecture? The reference architecture is a baseline blueprint document consisting of high-level drawings, knowledge-based articles, and proof of concepts relating to your specific industry and application. Included in these packets are accelerated toolkits with detailed system configuration drawing examples and application code, and in some cases, some SCADA screens to help you accelerate the development of your application. Essentially, a reference architecture is a collection of tested and validated architectures. And what I mean by that is what you see in front of you, this architecture is physically deployed in our HQ in Cleveland. And we benchmark and test that continuously as more equipment is added, as we develop more relationship with partners and introduce more IoT devices. It's physically tested, benchmarked, and we call that characterized, meaning that we understand and know the throughput of the actual architecture itself, depending on the device itself as well. So think about that. When you're building a CPWE architecture, you're not reinventing the wheel for anything. All you're doing is literally off the shelf, out of the box, deploying, following the rules, and you'll be conformed to all the different governing bodies and accreditation systems out there. I don't typically like to spend a lot of time on this slide, but I do in this case, so I'm not sure how many people will actually read through the documentation. These are the different chapters or the different tenets, the different areas that the CPW covers. So what I've presented so far is really the baseline document that talks about this architecture. But once you've established this, there's other areas, and I'll just briefly run through each one. One of them is sync. So how do I synchronize all the devices across the system? Very important when trying to diagnose from a security aspect, when someone attacks this machine, that machine, the next machine, how do I sequentially visualize the attack with a synchronized time environment? It also covers security. So how do you, and I'll touch on that one of these two a bit more detail. How do you deploy an industrial data center? So how do you take the system, virtualize it, and deploy a physical infrastructure there to be able to host these called industrial data center? How do you connect to the cloud? How do you configure device level ring? I'll touch on this one a bit later as well. If you're an OEM manufacturer, original equipment manufacturer, how do you take your machine and join it into an architecture? So if you're joining a CPW, how do I develop my network on the machine to accompany this? How do I develop industrial firewalls? How do I do VPN connectivity? How do I migrate from older technologies to the CPW? How do I develop resilient networks? We spend a lot of time on the IDMZ. A lot of customers ask me, how do we do an IDMZ? So there's a document that describes all the rules required. CPWE identity and mobility. So how do I do kind of wireless access and identify all the entities within the system? How do I do network address translation? This is utilized in the event of a machine being delivered to the environment with a set IP range, which cannot be changed. And I need to somehow translate that, give it another IP address through a mechanism so the rest of the system can see the equipment. How do you create WLANs? SIP security, I'll cover a bit more in detail, and then parallel redundant protocol. So a bit of a mouthful there, but essentially that is the essence of the CPWE. These documents that your customers can download and be able to start deploying through documentation. I mentioned before that accompanying the relationship with Cisco as well as the CPW is a complete range of switches. And based on the drawing I'd shown you earlier, every single one of those positions within the architecture can be solved with a Stratix or a Cisco switch. So really starting at the very bottom of here's a 2000 unmanaged switch typically found on machines, very similar to the 2500, you know, up to a max of 8 or 16 ports. The Stratix 6000, slowly moving up to more managed systems. The 5700 is slowly being replaced by the 5800. But we're certainly starting to see a lot more, or we should be seeing a lot more managed switches in the environment. If you're in an environment where there's unmanaged switches, would be a reason to have a discussion. We just recently, or not recently, a little bit ago, released the 5800. This is considered a high performance switch. It's replacing the Stratix 8000. It gives you the opportunity to add expandable modules, so giving you a range of ports up to 26 ports. Excuse me. And then as soon as we get up to the distribution layer, the central area of the CPWE, we start using gigabit backbones, moving into either a DIN rail mounted 5400 or a rack mounted 5410. So really a one-stop shop if you're looking to accompany physical devices with that Ethernet architecture, the CPWE, and really what I'll be doing later on with the demo of the software, I'll show you how to deploy these switches into a CPWE architecture. The secret sauce behind a Stratix switch is the ability to drop that switch into a PLC program. The protocol behind that is called SIP, the Common Industrial Protocol. And what we're seeing over here is the programming tree of a PLC. I've got an Ethernet branch over here, and I managed to find the Stratix 5700 by part number. I've dropped it into my PLC program, and then I have access to all the tags that are associated with that PLC, with that switch. And that gives me the ability to start creating screens. So these are faceplates available in FactoryTalk View, a range of faceplates for all the switches. And I'm able to click on these, and I'm able to look at the status of the ports. I'm able to look at, in this case, behind you is the device level ring. It lists out all the different nodes on the ring itself. It gives me diagnostics capabilities. Essentially, this brings the network forward to the operator or to the engineers, as opposed to having to pull out specific tools to be able to analyze these pieces of equipment. A very powerful concept, and something that's overlooked a lot of times with regard to the capability of the Stratix. This is the secret sauce. This is why it's a beneficial product for a customer. The ability to do this, when you fault finding, it's incredible. There's nothing better than this. Not to forget that the partnership also includes Panduit, and Panduit offer these integrated network enclosures. So it's really an off-the-shelf enclosure. Inside the enclosure, you'll have either a single switch, or if you require a duplex fail-tolerant enclosure, they can do that too. But essentially, all the different zones that you have over here, Panduit have these logical enclosures. You can purchase them from them, easing your pains when trying to create these infrastructures yourself. So whether it be the industrial data center connectivity, or you're trying to do the mainframe, or just basically cabling solutions at the bottom. Panduit also offer an unparalleled guarantee on their networking solutions. I don't want to be incorrect here, but there's a very long time insurance on the cabling system themselves. So if you marry the Cisco technology with the Rockwell OT experience and the Panduit infrastructure as far as the cabling and the enclosure zones, it's a very powerful statement and an architecture that will be enjoyed through the years to come. Excuse me, I heard a frog in my throat. So I'd like to look at some of the key tenets of the CPW architecture. Again, looking at this diagram, I want to start on the top right over here. We spoke a bit about the smart IoT devices. As long as they're Ethernet IP, industrial ready, hardened and tested and conformably tested by the ODBA. One of the areas about the managed infrastructure is that you have to have the ability to create zones. You have to have the ability to do resiliency and security and diagnostics on the system. When it comes to zoning of the system itself, you looking to logically segment those systems based on standards. So you want to be able to do that with physical applications, so switches and firewalls, etc. But you also want to have the ability to do that in a software realm. So where on the switch, for example, could I create a zone? Your switches should also have the ability to do different layers. So whether it's a layer 2 switch or a layer 3 managed switch. And something I'm going to cover in a bit more detail is the software-defined virtual secure group tag. So a way to segment a network through software. The system should be resilient, should have the ability to provide a physical resilient layer. And this should have resilient pathways, so duplicate pathways in the event of a cable breaking. And then your architecture should also have the ability to have wireless connectivity as well as firewalls. One area that's becoming more and more critical, and I mentioned earlier, is the synchronization of time and quality of service, as I mentioned, with regards to the types of traffic. When you have a large sprawling architecture like this, and each one of the different zones or each one of the different means are marching off on their own time, it can be incredibly difficult to not only isolate issues and security flaws, but your machines themselves may be out of sync. So that's something that's got to be, it's precision time protocol that gets deployed across the system. It should be convergence ready, meaning that you should have the ability to do the NAT translations I mentioned earlier, and should have the ability to do wireless mobility and a holistic defense in depth approach. So these are all key areas of the tenets. I'm going to break down 3 or 4 of those in a bit more detail. What we're looking over here is putting into practice, which is the plant-wide zoning, which entails micro segmentation of the environment. The goal is to reduce large fault domains and make it more difficult for an adversary to penetrate the elements of the system. So if you look at this system over here, Instead of one large flat network, we should be breaking it down from, there's your control room, zones within the environment, then taking it even down to what's called micro-segmentation. And the purpose of this, we're looking at packaging, processing, and material handling. The packaging networks would require high-speed, low-latent motion characteristics. So you probably got drives with multiple axes around that area, whereas material handling could be a slower pace, and this could require long linear networks because we have conveyor operations. Or the processing, so the liquid processing, could be largely populated with instrumentation, with a large demand for high available solutions, so redundant pathways and networks. So for this, you can see we have to have the ability to be able to segment these with some kind of software utility. And this is called software-defined security group segmentation. This is a technique or a feature available in Cisco switches. I guess it's pretty similar to SIP security in the fact that you can isolate areas, but essentially what we're doing over here is we're creating these different groups, and we create a role-based enforcement table. So what I'm showing over here is I've created this group, and within the groups I've associated a tag name with each one of these devices. And I can start restricting SGT30 from talking to SG100 by doing a cross-reference table. I'm not going to get too much detail over here, but something certainly overlooked. If you want to learn more about this, just do Cisco software-defined security group segmentation. It's embedded in all the switches. And I don't seem to see a lot of customers taking advantage of this technology, but it's certainly a very powerful, easy way to start segmenting the network without lifting up switches and replacing a whole bunch of stuff. So the CPW also provides guidance around network resiliency. It gives customers a choice of redundant protocols. In most cases, we're trying to find something suited for the application needs, as I mentioned before about the disciplines. In some cases, they may require ring topologies with extended diagnostic capabilities, or in some cases, they're looking for embedded switch technology with dual ports. That means that the devices themselves have 2 ports embedded in them to be able to create these rings. In other cases, dual parallel redundant protocols, and I'll touch on these a bit more in detail as well, where we do not want to use a ring, we want to use a star configuration, but have the ability to add some form of resiliency into the application. So I want to dive into these a bit more in detail, really around not so much about the protocol itself, but what the CPWE documentation provides you. So just quickly touching on device level ring. You're looking at 3 different areas over here, what we tested over here. Device level ring it's called embedded switch technology. What happens is we have a protocol that creates this ring, and somewhere within the ring, the protocol is broken by the protocol itself. And in the event that something breaks, that break reheals and the ring continues functioning. Probably did a bad job at that, but the benefit of device level ring is the convergence time. If the ring breaks and the protocol has to heal at that certain point, the time that it takes to reconverge is called the convergence time. If we were using something like spanning tree or rep, you could be upwards of 80 to 100 milliseconds. In the event of having a motion application, we're down to the milliseconds, 10 milliseconds. Device level ring has the ability to do a 5 millisecond recovery rate. And over the years, we've deployed more documents on the CPWE around white papers and design implementation guides. And what I'm showing you over here is 3 different technologies. Well, we've created a ring of switches. So with the new 5800, the new 5400, we can do a ring of switches up to 24 switches. We've tested a multi-ring, so it contains multiple equipment, including switches, up to 50 devices. And just recently on the 5400 and the 5800, if you deploy the expandable modules, we can start deploying multiple rings through the same switch, up to 3 rings. This is very convenient if, for example, you want to have a ring for PLC to PLC communications, or another ring for the SCADA communication, and maybe another ring is for safety equipment. So really, device level ring, in my opinion, is the go-to protocol when connecting PLCs to I/O for multiple reasons. And in the documentation, you'll find extensive guides, but more importantly, there's specific documentations on how to set up a Stratix 5400 for these different technologies. Parallel redundant protocol, not a ring protocol. I guess it could be a ring protocol, but it's a little different in the fact that it doesn't converge. There's no time for the ring to heal in this case. The way parallel redundant protocol works is that there's two LANs, LAN A and LAN B. You'll purchase a particular card, it's the 1756 EN4 TR for the controller, and then we have a variety of end devices, I/O platforms, drives, etc., that have the embedded PRP technology. So how it works is the data will leave the controller, the information will traverse across both the LANs at the same time, and whichever LAN gets to the I/O first will be consumed, and the other one keeps going. The benefit of this is that you can have large, complex, starred ring networks. All you're doing is replicating. You're creating one network and then replicating the identical network in LAN B. And as I mentioned before, there's no convergence time. So anyone looking for a critical area where convergence time is an issue, PRP is the way I would go. If you do not have a PRP device physically to connect to, we can introduce what's called a red box. So we would bring the PRP dual networks to the red box, having the redundant protocol come there, and then connect the individual devices to that red box. So again, white paper detailing this, some use cases, the design and implementation guide, but more importantly, really detailed design guides around how to use the Stratix 5400. In this case, yes, the EN2TP and the 5094 IO. So it'll give you a breakdown of examples and give you code to be able to use within the environment. SIP-Sync, I've mentioned this before. I'll keep reiterating SIP-Sync because I'm primarily involved in security, and this is becoming a major issue with regards to synchronizing systems across a large converged wide Ethernet system. So the challenge is that on the IT side, the time protocol is called NTP, National Time Protocol. Whereas on the OT side, we use something called PTP, which is Precision Time Protocol, down to the millisecond. So the point being is that the NTP time protocol is not appropriate for the OT space, and we have to find a way to bridge between the two. So in most cases, the time itself is coming from the IT. We need to bridge between NTP, bridge across onto the OT space, convert that to precision time protocol, and then synchronize everything. Again, detailed white paper on how to do this, a detailed design and implementation guide, but more importantly, how do I do this? So it talks about some modules. This module may be no longer available, but there's other methods to do this. But essentially, it's a detailed document on how to time sync with SIP across the entire network so that you can synchronize the system for particularly on large applications. An area that I've been focusing on a lot lately is the security area. Many places in the control system to attack, both from a protection standpoint as well as from an attacker perspective. If I start focusing on the orange, which is the control system engineer, the CPWE, it does reference all these different organizations, so all the national standards required for development of this. It goes into a lot of detail around control system engineers. So if you're someone looking to put hardening policies on a controller, so what should I do with regards to blocking an unused Ethernet ports? How do I do encrypted communications? How do I do zoning? How do I do application hardening? How do I reduce the surface attack space on my control equipment? So detailed documentation around that, or perhaps use a control system engineer that's working between the PLCs and up to IT, really focusing on the SCADA layer. It'll give you detailed information on how to do, for example, remote services, or how do I do the computer hardening? And more importantly, how do I start doing things like secure wireless activity? And then all the way up into the IT security consultants, which are really looking at the Active Directory, really pressing down into the IDMZ and trying to figure out from the two other entities, from the control system engineers, hey, how do I get the information from you guys into my IDMZ and safely and securely bring that up into the business system so we can use the information? So a lot on this slide over here, a lot of documentation around SIP security, which is my next slide. So SIP security, one of the challenges so SIP security is a method to encrypt the protocol itself. When you deploy FactorTalk security or any software-based security, it's essentially locking down the ability to use the software onto the physical application. So say, for example, you program a PLC. use FactoryTalk security to lock down the PLC, my user access control, it stops that aspect. But if someone had to get onto the wire, not using traditional software, and starts listening, it's called the man-in-the-middle attack. You would not be able to solve that person, be able to either sniff the information or inject something into the packet that could cause disruptions to the operations. If that's the case, we have to find a way to encrypt the communications. And that's what we do with SIP security. So first we'll do authenticity. There'll be a certificate exchange between the two devices. We'll do integrity, and then we can do confidentiality on the data itself. So encrypting their communications and then unencrypting it at the other end. Completely eliminating the possibility of a man-in-the-middle attack, someone be able to penetrate the system, bypassing all your software security realms, even bypassing your segmented switch areas. If they had to plug into the network, they would not be able to hear or listen to anything. So something new within our industry. There's other competitive solutions out there with regards to protocol encryption, etc. We have found that the SIP security, it's so embedded into the Rockwell hardware and software, and with FactoryTalk Policy Manager, we're able to create what you see in front of you here, which is a really in-depth, segmented, secure system all the way down to the protocol. So again, on the documentation for the CPW, you'll get a white paper, design guide, and it really outlines in detail how to use FactoryTalk Policy Manager, how the SIP security technology works, and then it really focuses on the IE 62243 3-2 and the 3-3, which is for the system security. How do you meet those standards utilizing SIP security? Okay, so some of the key takeaways. Rockwell and Cisco have been doing this for it's more than 16 years now, maybe like 20 years. We continue to work together. We continue developing physical hardware together. New Stratic switches are coming out every year. We continue to add more chapters or more tenants to the CPWE as we start expanding into more areas in the architecture. At this point, we have 17 tested and validated architecture. So I want to just reiterate the validated architecture, which is a very powerful statement. This is not something that we're just putting together on paper. It's a physically designed and characterized benchmark system out there, and it really focuses on a multidiscipline environment. So creating the correct network that's appropriate for the application to be able to make the systems run. So proven reference architecture, as I mentioned before, in my experience, the more documentation we have to enable the different entities, it's easier to have conversations between OT and IT. And we're certainly expanding the ecosystem with Panduit and making the system extremely reliable. There's about 5 of me across the country that can help customers do workshops. We're going to help you identify the gaps in your systems. And then I see I'm running short on time here to be able to help you address these systems. So I'm going to break out of this real quick. I'm going to jump into a demonstration. This tool is called Integrated Architecture Builder. You can Google Rockwell IAB. You'll end up on this page over here. It's about a 1 gig download. It's pretty big, but a very powerful tool in the fact that you can design systems from scratch through a software realm. This is the application over here. I'm not going to get into a lot of detail, but what it does have is an option to create a CPW architecture. So what I'm going to do is I'm going to go to new project. If you were doing things like creating new hardware applications or a new network or new software, if you're doing a plan PX system, or maybe just building a control logic system, there's these different wizards that'll step you through how to create an architecture. And what I'm going to do over here is I'm going to jump onto the CPWE layout wizard. What this does is it's going to step me through questions. And when I'm done, it's going to produce what you saw, the CPW architecture with a real system behind it, with the bill of materials and all the interconnectivity between the devices, and the operations will be completely solved by this application. There's no reason to be concerned about anything not being able to work, because it's simply going to be a reiteration of the CPW. In my case, I'm going to add an enterprise zone, which is the IT space. I'm going to add an IDMZ, what we spoke about. I'm going to add the level 3 site operations, which is the control room. And in this case, I'm going to add 3 different zones. Press OK. It's going to give you a couple options over here. It gets down to, you can set the IP addresses for all your devices. I can come down here and change, for example, by default, I'm using the Cisco Firepower for the firewall. But if you're not sure what to use, this will open up a panel and you'll be able to filter through the different kinds of switches available, and then choose one of those and change. Perhaps you want to use Fortinet instead of Cisco. Further down, we can do change things like the distribution switches. In this case, we're looking at the Catalyst 3900. And in the event that you're not using any of these, there are generic things available. All the way down to the site operations, all the way down into your cell zones. You can choose the kind of protocols you'll be using, spanning tree, ether channel, in this case, ring or rep ring, whatever it may be. You can change the switches, Stratix 5200 by default, and I press finish. Take a few seconds, and boom, right here, we have a fully developed CPWE ready for you to start creating an application. So say, for example, I want to start developing my application down here. The first step would be to add a PLC. I'm going to go 1756-EN2TR, which is a communications card. I'm going to do a search. I'm going to grab the product from here. I'm going to drag it onto the switch. It gives me a plus sign indicating that it's a valid connection. And I've now started my PLC application. And I can double click on that and start dragging more and more things into the system. So ultimately, a very quick way to start your network architecture. You know that it's designed according to the blueprint, the guidelines of the CPWE. And each one of the products that I've mentioned before are available from the Stratix catalog / Cisco catalog, depending on where it is on your journey. Okay, I want to thank you very much. I'm going to jump to the chat and some questions, and I'll stop presenting at this point.